Welcome to today's Explainer. July 2nd is literally one of the absolute greatest dates in the entire history of mathematics. And before we jump in, we're going to follow the script structure outlined in the source document titled ENG today to keep things perfectly on track. We're following this sort of magical, invisible thread, because on this exact calendar day, spanning completely different centuries and totally different countries, a handful of brilliant minds unlocked the tools we use for literally everything today. We're talking navigating our roads, protecting our internet data, rendering our video games, and, oh yeah, understanding how massive stars explode. So, let's get into it.
Okay, let's dive into this timeline. As you can see, we're going to be looking at 4 specific names today. Bartholomeo Pitiscus back in 1613, Choi Seok-jeong in 1646, Mário Schenberg in 1914, and Rudolf Kalman in 2016. Let's just take them one by one.
But first, think about this for a second. Have you ever actually wondered how your favorite video games create those massive, perfectly rendered three-dimensional worlds? I mean, when you're looking at a flat digital screen, how on earth does it build a perfectly shaded mountain or a hyper-realistic city street out of just a bunch of pixels? Well, that brings us to part 1, Bartholomeo Pitiscus, who died on July 2nd, 1613.
Pitiscus was a 16th century theologian and mathematician, and he gave us something absolutely fundamental. In fact, he's the guy who literally coined the word trigonometry. He published this massive, incredibly detailed guide on how to calculate the exact proportions of triangles, and get this, he worked out the math by hand to 22 decimal places. 22! Now, why does that actually matter to us today? Well, because every single 3D shape in our modern video games and computer graphics is basically just thousands or even millions of tiny flat triangles stitched together. It's like a giant puzzle. Pitiscus showed us exactly how to calculate and manipulate those triangles, which gave us the foundational geometry our computers still use to render 3D spaces right now.
Without his triangles, our digital worlds would be completely flat. It's just an amazing thought, isn't it? A mathematical concept that was finalized in the early 1600s is the exact same engine running your high-definition graphics card today. It's wild!
Still on July 2nd here, but now we're going to jump forward to the year 1646. We're moving from Europe over to Asia. And honestly, the ideas are about to get even more complex. So picture this. When you download a photo, a song, or some massive file over really choppy internet connection, how does your phone keep from just completely scrambling the data? Like, how do our devices actually know if a tiny piece of information got lost in transit? And better yet, how do they magically fix it so your file isn't just totally broken? This brings us to part 2, Choi Seok-jeong, born exactly on July 2nd, 1646. So the crucial point is what Choi Seok-jeong actually achieved in his famous book, Gusuryak. He was studying the ancient Asian philosophy of the I Ching, looking for patterns of dynamic balance in the universe, right? And in doing so, he ended up inventing what we now call orthogonal Latin squares of order 9, along with the hexagonal tortoise problem. Now, putting the academic jargon aside, what are those? They're basically these numerical grids where numbers are arranged so perfectly that no rows or columns ever repeat. He figured out how to lock information into these perfect self-checking patterns. And centuries later, this exact mathematical concept became the very root of modern coding theory. It's literally the mathematical armor that protects our data today, making sure that when your digital files fly through the air, they arrive perfectly intact. The ancient magic squares that secretly protect our digital data today. Just let that sink in for a second. It is absolutely mind-blowing to realize that ancient philosophy regarding the balance of the universe directly evolved into the error-correcting codes sitting inside your smartphone right now. Okay, same dates, July 2nd, but we are jumping way ahead now to the year 1914. And we're going to leave our everyday digital devices behind for a minute and look way up into the night sky. Have you ever looked up at the stars and wondered, how do we actually know how they die? I mean, when a massive star collapses and explodes into a supernova, it's light years and light years away from us. We obviously can't go there to measure it, so how in the world do we know the exact physics behind the biggest explosions in the universe? Part 3, the brilliant Brazilian physicist Mário Schenberg, born on July 2nd, 1914. Schenberg, working alongside another giant in the field, George Gamow, mathematically unlocked the secret of stellar collapse. Together, they discovered something called the Urca process. They proved that deep inside the super-hot core of a dying star, energy is suddenly and rapidly drained away by these tiny, invisible, ghost-like particles called neutrinos. Schenberg actually joked at the time that the star loses its energy as fast as a gambler loses money at the Urca casino in Rio de Janeiro, which is pretty funny. But because of this massive, rapid drain of energy, the star can literally no longer support its own weight, so it collapses inward on itself and then violently explodes outward.
The man who mathematically figured out how the universe's biggest fireworks are made. He couldn't physically fly to a dying star, obviously, so he just used the sheer power of mathematical physics to peer right into its core. Just incredible.
Let's move to our final stop and see how this all builds together. We are jumping to the year 2016. Now, we literally all use this every single day. Why does your digital map always know exactly where you are? Even when you're speeding down the highway, surrounded by massive skyscrapers, dealing with patchy cellular service and a bunch of satellite noise, how does that little blue dot know exactly where to stay on the road?
That brings us to part 4. Rudolf Kalman, who passed away on this very date, July 2nd, 2016.
Kalman developed something completely revolutionary called linear filtering, specifically known as the Kalman filter. To put it in super simple terms, he created a brilliant mathematical algorithm that takes in a whole bunch of messy, noisy, uncertain data over time, and it cleans it up to accurately predict where something actually is. It essentially filters out the chaos. And this is the exact math that takes those weak, noisy, jumbled signals bouncing down from satellites in space and magically calculates your precise location on Earth in real time. Every time your map recalculates a route, it is doing Rudolf Kalman's math. Without his linear filtering equations, autonomous cars couldn't drive, rockets couldn't navigate, and let's be honest, we would all be hopelessly lost trying to find our way around a new city. And this brilliantly illustrates our grand wrap-up for today. Every single person we met in this explainer, across completely different centuries and countries, they all fundamentally ask the exact same question. What is the pattern hiding inside the chaos, right? Pitiscus found the pattern in physical spaces. Choi found the pattern to protect complex data. Schenberg found the pattern hidden inside dying stars. And Kalman found the pattern buried inside noisy satellite signals. And simply because they asked that question, our world today has pinpoint GPS, stunning video games, error-free internet, and a much deeper understanding of the cosmos itself.
It really makes you wonder, doesn't it? As we look at the calendar, who is going to be the next brilliant mind to discover the impossible on July 2nd? What patterns are you going to look for in the world around you today? Thank you so much for joining me on this explainer. Keep wondering, keep questioning, and I'll catch you next time.